Welcome back to Concrete Conversations. We're here today in iCoat's offices, and we're looking at the process they go to make sure every batch of resin that comes in comes out perfectly.
Sure.
And it can be monitored over time, because if there ever is, it's chemicals, right, we're dealing with.
Right.
If there ever is issues, we can track it back to exactly where that issue came from.
Exactly.
Okay, so I had some questions. I'm going to hold my notes and go through some questions here with you, Tim. So, the first question was really like, what steps do you take during production to ensure that the resin's always going to be perfect, crystal clear?
Well, it actually starts before production, because we have to select the best raw materials. There's a lot of inexpensive things coming in from China and such, but we source everything within the United States as far as our raw materials go, so that our customers don't have to deal with issues that are caused by that. So that's before the production starts. Once the production starts, we do a lot of testing along the way before it even goes into a bottle, and then after it does go into a bottle, before we send it to our customers, we always do many tests, again, just to ensure that consistency batch over batch meets everybody's needs.
Now, we've seen emails come in, we've seen notes in our CRM from people who've bought cheap goods from other places and they have problems. This is one of the steps to help prevent it. Do we even think our competition or others out there are doing any sort of batch testing, or is this something that is over and above as a best practice for a business?
I think we probably do significantly more testing than anybody else does. I already know that. We go way beyond crazy, so that that consistency matters to us. But I don't know. I don't know if anybody does any testing. I highly doubt it. But we test before bottled, and after.
Right, so let's take one of these here, just for the audience here with us today. Tim, take us through the process, what happens when every batch comes.
So again, we do a lot of testing before it goes into the bottle. We do drawdown testing, which gives you flow. We do bubble release. We do things that can be tested that are important if we need to modify the formula before it goes in the bottle. But once it does go in the bottle, we wait at least 72 hours, because we found that's a magic number. And then we do a lot of casting. So we'll make it cast with an A and a B, obviously. This is a 6x6. It's a 1/2 inch to 5/8 inch thick. And we keep the batch numbers right on here, so that if we ever had to go back, so we keep liquid retains. We keep liquid retains for...
And they've got the batch number on as well.
They've got the batch number that corresponds to this. Now, we keep these here for a year, and then we keep them all together for 5.
Wow.
But we do that, and we do... we cast 6 of these, just because that's how much we mix up. We mix like a quart of material out of these, and then and we cast one of these.
So you do a ring holder as well?
We do a ring holder, just because this gives you a really good idea, because bubbles tend to... These are cast in really cheap molds. So we can test how many uses we can get before it degrades the mold, and it's a lot. But they tend to collect a lot of bubbles right around this area right here. So This is a real good indicator that we're getting really good bubble release, because we don't manipulate anything. We pour it in there, we mix it, we pour it in there, and that's the result.
Right. So are you heat gunning any of this as you're doing it, or is it just natural?
No, we don't. We just pour it in and monitor the bubble release. We don't use a vacuum chamber. We don't do any heat. We don't do any torches. We're just looking to see what the resin will do completely on its own.
Wow, that's really, so that's a base standard, right? Because I look at these and I don't see bubbles in them. They're clear. I see obviously the batch numbers on each of them, but yeah, that's amazing. So no vacuum chambers, no heat
That's
guns,
just
nothing.
how it comes out.
Just really straight raw. So you go through this testing. Do you test under different conditions? Because I think some people would say, well, how do we account for humidity? How do we account for different temperature areas? how do we account for that sort of different situations?
The idea is we're doing a chemical reaction. So every time we mix an A and every time we mix a B, provided that they're the same epoxy or the same kind of epoxy, we're expecting to get the same thing. So as far as temperature and humidity goes, we test everything here.
Right.
So we're at 78 degrees, controlled humidity. It's a laboratory here. So adjusting for we want everybody to recreate the environment that they're doing as much as possible every single time. So that you'll get the same reaction with the same materials, with the same conditions. Yeah, and we realize that that's kind of hard to do, but there's ways to keep your molds warm by using a heating mat in the winter, cooler in the summer with air conditioning, things like that, a dehumidifier if necessary. There's a lot of different things that go into it to keep everything as consistent as possible. We're going to make sure everything's consistent. In your own studio, you need to be as consistent as possible.
And so it sounds like there's a set of consistent best practices to get the best result out of using resin.
To get the same result. Yeah.
Right.
We have the same result every time, especially because if we're pouring in multiple layers, we want this layer to be the same as this layer.
Right, got it.
So it's important to monitor that.
Right, and we're going to show people in a minute how to warm epoxy to get it, before you mix it, to get it to the right temperature, how to use some of the accessories as well that come with this. But, okay, so there's that. And we've got examples of things on here. So people always ask this, and this is the thing, right? And I don't see any of this yellowing. Do you ever get anything that yellows? And
well, all epoxies are going to amber a little bit over time. Right. We use, again, it goes back to the raw materials. If you're using clean raw materials, you're using top-notch raw materials, you're using the state-of-the-art UV resistance, you're using everything that's just clean that we know we can control. You're going to get a little ambering over time, but we wouldn't expect it to be anything that's radical where it would ruin a piece. Like, I'm sure a lot of you guys have seen stuff that's gone crazy yellow. We test after 72 hours because there's certain things that can manifest in a formula once it starts reacting. It's like a recipe,
right?
Like spaghetti's better the next day, right? So we want to make sure that after 72 hours, we do all the testing so that we can be sure that it's going to stay that way.
Gotcha.
Yeah.
And so for anyone out there who has a company telling you that their epoxy never ambers, they're lying?
Yeah. There's
it just doesn't happen.
It's to what degree and the way that the pieces are, it's really, it's not anything that's a concern. It's very long life expectancy and limited ambering over time if it's done correctly.
Right. So, we've got our samples, we've done our testing. You hang on to these batches to make sure that you're seeing how they're changing over time. Uh-huh. And within this building, it's probably changing in the summer. It gets pretty warm in here, right? And
78, 79.
Okay, so it's pretty tight variance.
Yeah, we keep everything really controlled in here.
Right. What certifications and what standards do you hold the epoxy to? What standards could we tell the audience the actual epoxy meets?
Well, many of our products meet LEED Platinum standards. And that's what we strive for on everything. Also, we want to make sure that we're food grade,
right,
so that it can be used USDA approved as far as food prep areas go, and things like that. So those are really probably the two important ones because they get, obviously we want to take care of the environment. We don't bring in materials from China because there's absolutely no control of quality or we have an EPA here that monitors everything that we do. So I think that's the two important ones.
Right.
Is it going to be safe if it touches my food? Is it going to be safe for the environment? Yes, on both counts.
So this is great. We've got all the ways that we're looking at. This goes back a year plus, right, with what you keep in here, and you keep more of these.
Oh yeah. This is over the course of the last year and a month.
Gotcha. Okay, and they'll just keep rotating as new batches come in,
yep,
and you move it along.
And all this will go into a closet.
Gotcha. Mm. Okay, so you'll still be retained.
Yeah.
And that gives us consistency, right? So, what is the expected lifespan? So someone's looking at this and they're saying to themselves, okay, you're holding it, but if I make a flower preservation out of this, what am I looking at lifespan wise, where it's going to stay good quality?
That's completely hard to answer that question, because our customers do everything a different way.
Right.
If they have controlled conditions, it's going to be a lot longer. For instance, I brought this piece out. This piece right here is from 2021.
Okay.
That's the oldest
So
one.
4 years, yeah.
This one is from last week.
And
So as you can see, they're very similar.
like, you can tell I couldn't tell it.
But again, one of the big things is once the project leaves our customer's house or studio or business or whatever, they're no longer in control of that.
Right. If it's not stored correctly.
If it's not stored correctly, if it's not, if it's put out in the sun, that could be a problem. If it's overheat, that could be a problem. Even a bigger problem that we've found out about over the last couple of years is if somebody doesn't unbox that and it's still breathing.
Right. Okay.
And it's breathing for a few weeks, a month, 6 weeks. And it depends on how quickly it's put into the box. But if it stays in the box, it can create premature aging by just being in the box for an extended period of time. So we want you to get that out of the box as soon as you can and put it on display.
Gotcha. So yeah, okay, so we've got all of these samples, but I'm sure there's times when you have customers that will contact you and they'll be like, I'm having issues with my resin. It's not turned out the way I want. This not happening. How do you go through that troubleshooting process with them?
Well, if somebody sends in a piece, if somebody calls about a piece or something that they're having bubble release problems with, or an early ambering or something that's happened to them not setting up, then I'll come over here, pull the retains from the batch, recreate the situation they've got as closely as possible, and generally everything's fine. It's just a matter of eliminating this and then troubleshooting with the artist what it is.
Right.
And generally it's, oh gosh, I mixed 2 parts of A, or something happened, or something got in there, or whatever. It got overheated because the phone rang or something happened. But we can come back to it and work with that customer to make sure that they won't do that again or something.
So we've had people talk to us about they'll mix more of B than with A in their mixes. Is that a good idea, bad idea? And talk us through the
No, it's really not. We want to have equal amounts. This particular epoxy is a 1-to-1. Some of them are 2-to-1. We even have 3 and 4-to-1s, but this is a 1-to-1. So if I've got this amount of A, I want that amount of B.
Right.
What happens is sometimes people weigh it, and they don't account for the weight disparity, whereas the B weighs 18% less than the A. So if you're weighing it, you're going to end up with
a problem.
You should be putting in 100 grams of this and 118 of this. But if you're putting in 100 and 100, you're going to end up with more need for more B. So we get that from time to time. But or the markings on the cups are wrong. And people think when they're buying a cup from China that it's marked properly, and a lot of times they're not even close.
So it could be here.
So
it
could be off by
right.
several percentage points. So over a period of time, I'm using 5 gallons, I'm using 15 gallons, I'm using 35 gallons, whatever. You're going to be off,
right?
Because you're most likely people, measure the B the same way every time. First, they measure the B or the A or whatever. But if the markings are off and they're doing that same thing every time, then you're going to end up with a problem.
So that people aren't freaking out, right? That there's an issue. Because, of course, we've probably got people at home right now saying, I don't know, I may be this much off with B and this much off with A. How much of a variance in it big starts to become a problem? Or when should they...
There's a big gray area in there where it's, if it's 52 to 48%, you're good. If it's 60 to 40, we're not good anymore. So we
Right.
don't want a lot of extra of either one. Because they can both cause problems.
Right.
They're going to cause issues if the idea is we like to make them equal as possible.
Right.
But you're still going to cure out, still going to do this and that, unless you're way off.
So
you don't want to be way off.
So once you've got those, is the technique to mix in to make sure that, because I imagine someone would say, well, maybe it's sticking to the side of the bucket. Is there a mixing techniques to get the best mix of your 50-50 or? Would you
there's
recommend?
A lot of different ways, as long as it's getting mixed. I like to warm it up before mixing. We're going to
makes
do that.
it easier to mix. Right?
Makes it easier to mix. I mix with a drill because it's faster,
Right.
And I warm it up so it's not good. If you put cold epoxy and mix it real fast, it's going to have a lot of bubbles in there.
Right.
Because the viscosity is significantly different with different temperatures. So even a 2 to 3 degrees temperature swing can move that resin viscosity 5 or 10%.
Right.
So the idea is we want to warm it up, and I like mine at 82. I think it mixes the best, releases bubbles the best, isn't getting it too hot where it's going to take off chemically early. That's what I like to do.
So we were geeking out a little earlier that there's probably some sliding scale of viscosity to heat.
Sure.
For the super epoxy geeks out there would probably be something fun to have a look at, but wouldn't mean much, right?
Yeah.
But they've gone to that optimal temperature, right, to mix these products out. Is the HV epoxy the same temperature to mix the countertop epoxy is to mix the depth epoxy, or are they different temperatures to get the best results?
They're different. Like our depth, which is so very thin,
Right.
that it really doesn't matter. We don't want it to be 30 degrees.
Right,
but,
yeah.
but any environment inside of a studio or a house, it would be fine. This one here, I like it at 82. The countertop, which everybody knows is a CT60, is the top coat. It's much thicker than this, much thicker. So I like that to be about 85.
Oh, okay.
With that, you don't have to worry about creating its own heat because it goes on such a thin mill, and it's just irrelevant. Once you get it out of the bucket and down, it's not going to have enough mass to generate its own heat.
Gotcha. Excellent. Well, this is great, Tim.
Yeah.
So I think it's a lot of good information for people out there and see the inner workings of iCoat products and the way we handle our epoxies.